Alright, how's it going, everyone? We're back to working on this lightsaber some more. We're going to be working tonight on the power supply and the batteries. So I made some mistakes when researching about lithium batteries and how I could connect them together and everything, and just assumed that it would all be good if I connected them in series and parallel without any issue, without anything in between them. Come to realize that that's not really the case. We can't really just connect them without any circuitry to help kind of even things out, because as they discharge and recharge over time, they will become imbalanced, and some will charge less than others and whatnot, and eventually we'll reach a state where like a battery is unusable or something like that. So we need to put in some balancing circuitry as well as a way to make sure that they don't charge each other if two sets in series or if two sets of batteries have a higher voltage than another. So that's what we're going to be working on tonight. And that is actually, it sounds pretty straightforward. It's quite a lot of components actually, so it is a pretty significant change in a lot of parts, especially if we can't use special chips for this sort of thing. So just bear with me, but this will be quite a bit of work, and it might take a few streams to get everything sorted out. So we will have to rearrange the schematic some and work through all this. Also, if you have any questions or comments, just let me know, and feel free to say hi if you stop by. Let's get to work. Let me turn the music back on. Alright, so I pulled up the power supply schematic here, and we're basically going to have to break this up, probably into several pages now. So let's just go ahead and start with that. Let's see. New schematic. Ready. Let's do battery connectors. There we go. And drop this right underneath the power supply. Alright, and somehow, can we cut and paste this? Because that would be awesome. Cut. And paste. Ah, there we go. Okay, so that looks like it'll work. We can add some stuff in there. We'll probably have to break this up to, we're gonna have to do a lot of work here, so yeah, we'll see. All right. And then the power supply schematic, we can probably slide this stuff over a bit. There we go. All right. So we've changed our schematic, but nothing's changed in the circuit so far. I'm trying to think of the best way to do this. You know, honestly, like, okay. The way this charging circuit and everything works, it may even make sense to do like 4 of these and charge each battery with its own like circuit setup, you know? As a, like, that would be a ton of parts and really annoying, but that way we could charge each one to the voltage that we want to. Huh. I'm not sure what to make of that. It seems like the best option in a way. How big is this chip and what does it look like? BQ2057. Is it going to be really annoying to do a bunch of these? It probably is. but it's probably also a really good idea. Give me a second. It's loading. Well, hopefully everybody's Tuesday's going well. Let me know if you got any cool stories or anything. I'm always interested. All right, where is it? Oh, come on. All right, something just went horribly wrong. Okay, there we go. We zoomed way in accidentally. Which one was this? U2. Where is U2 in this mess? Here it is. This one right here. So it's a pretty small chip. It's not huge. We might be able to get away with something there. It's just annoying to have to connect it, but especially all the components that go with it as well. But honestly, to make sure the battery's all charged without... See, what I'm worried about is this thing senses... This chip has a sensing mechanism for when the batteries are fully charged, and if it's sensing all of them, then when one of them gets fully charged, they would stop charging. So, how do we overcome that? And I think the only way it makes sense is to do 4 of these circuits. Yep. As annoying as it's gonna be, I think we gotta. How big is this R28? No, that's status. Wasn't there a resistor that had to... Is it this one, R3, that has to... No. There's one that has to let like a crazy amount of current through. And so it's sizable. What's this one? That's a cap. See one? I can't see anything in this view. I could have sworn we had there R3. That's a huge one. Is that on here? R4, R3. This one. Let me look up this part again, because I don't fully understand how this connects up and everything. I know I went through all this. This is why this is going to take a while, because there's going to have to be so much stuff I have to look up and figure out. I do think this is the right option. I think doing 4 of these charging circuits, 1 for each battery, makes a lot of sense. But I still need to make sure all it's going to work. Give me an example. I know there was an example circuit I was using. Sense VCC. I don't know that this is connected to the right line. I think this circuit is wrong. Or I'm looking at the wrong variant of the circuit. I don't think so. What is this part? PNP transistor. Okay. I think I didn't ever check. I think my stream's running okay. Yep. All right. The internet's running kind of slow, so I want to make sure there wasn't any super lag. Yeah, something is off about this. The way this is connected to the 5 volt here doesn't make a lot of sense to me. There, 0.1 microfarad. All right, that's correct. This resistor, I believe, should be up here on this line, on the AV4 line, like just before this transistor. And the sense should come from that. I'll show you what I'm looking at here. I think I made a bad assumption there because they power their VCC off of this DC input, which I believe you can do. I don't know what the, let's see, VCC supply from 4.5 to 15. Right, okay. Station input, VCC, supply voltage. Yep. I probably need to ignore what I have done. Obviously do VCC here, like the 5 volts here. Comp and TS. But here on, well, maybe not. Hold on. Let's look at the other circuit here. Yeah. Yeah, I think I need to take the USB 5 volt just completely out of this equation and just do this off of the input from the charge booster. How much current does this thing use? That's going to matter. 2 to 4 milliamps. Okay, that's fine. That's almost nothing. So I think we're okay using multiple of this circuit, but I think we need to correct it to look more like this. Okay. So step 1, fix the circuit. Let's just delete a couple of lines. All right, and then this is going to be 8V4, I believe. Yep. Okay. What is this again? 5.1 ohm. And this is 10k ohm. Okay, so that's okay, this is, yeah, a divider because our status pin will have issues. VCC minus 0.5. Oh, maybe we do need to do USB 5 volts into this, because that's going to control the logic. All right, let's see. I think this stays okay. I think we do need to use USB 5 volts here, but obviously some things are changing here. Okay, and what about the rest of this? That explains why they use such a big resistor on the example schematic for the output of the status line. All right, so we got 5 volts coming in there. This capacitor is correct. Oh man, but a lot of this is actually kind of confusing. What's let me see what the COMP one is. Charge rate compensation input. I just don't know enough, so I think I do have to just go back to what I was talking about before and use the 8V4. I'm going to have to change that voltage divider to make it safe for the teensy. All right, let's see then. And then this needs to be the same thing. So everything coming off this booster is going to have to power it all. Hopefully it's strong enough. I guess worst case scenario, if I ever fail it, if this doesn't work, I can still just plug the charge the batteries separately and plug them in. Okay, now that that's a thing, I might be able to connect this stuff back up. All right. No, I still need to do... Let's see, sense comes from the other side of the resistor. Yeah, this gets moved. Okay. And this gets taken out. That goes there. I think from sense... No, it doesn't. Okay, that gets removed actually. And this gets removed. That as well. This goes up here. Come on. Let's get a wire. Whoops. Missed it by that much. All right. All right, so batteries on the other side of that. And then this comes down. Here, let's just cross over here. And then drop it here. No, I didn't want it to do that. Go back. I don't want it to connect to that diode. Let's try again. Let's go here. Crossover. There we go. And then on this other side, 8V4. Oh, I guess we could just do it connected to this thing, huh? All right, I think that's right. That still works. This looks like it's right. $1K to the control. Okay, I think this is correct. Did I put a capacitor next to the battery? I don't remember doing that. That's suggested on here, 0.1 microfarad. I don't think I did. So we probably want to double check that as well. Okay, save that, save this. So now I need a new one of these for every single battery circuit. And each one's going to be charged separately. They're all coming in through the same thing, but man, this resistor might have to go up in value as well. Just to make sure we don't charge them too. It's not the issue of charging them too fast. It's draining this. That would be the problem. What's the lowest this batteries could go? It's 5 volts, right? So the drop here can be as much as 5 volts, or as much as 3.4 volts. It's like 700 milliamps. Yeah, that value definitely needs to go up because I think that most I can realistically expect is about 500 milliamps, and I need to send 125 to each. So 0.125. So 3.4 divided by 0.125, 27.2 ohms. That's about the value I need for each one. And then I need a capacitor for each battery. Okay. All right. I'm going to have to go through and change some parts here. So let's start with the capacitor. 0.1 microfarad. Already have one picked out. This number. There we go. Turn this off. Mr. C30. Let's see here. Where did this one go? Excuse me. I wonder if there's a way I can generate a bill of materials from this. I didn't have to last time because it was pretty straightforward, but this is getting to be a little ridiculous. So oh, this is going to be annoying for the status thing because they're all four going to be putting out statuses. I'm effectively charging 4 separate batteries at once, so I might need some like sort of multiplexer input or something because I don't think I have the I/O on the teensy for it. Sorry. I need 3 more, right? 1, 2, 3. I have just enough, actually. All right, we could probably go with that, but we might have to add something later if it gets too ridiculous. I love everything about how complicated this is getting. Okay. So that's fixed. Then we need to change this value to, we said 27.2 ohms. I got to figure out whatever the standard value is that's close enough to that. And then I'm also going to just pick whatever power rating this is. 2 watts. All right, in stock, active. Here, let me just bring this on screen. Cut tape. Well, let's go for it. Let's just go for it right now. 2 watts. Let's see what our options are. 27 ohms is a standard value, it looks like. Yep. Not 30, not 24.9. So 27 is the closest. So we'll just go with that. That'll be fine. It's close enough. All right, we got some serious resistors going on here. Some expensive ones. Jeez. Let's start with the cheapest. Nope, that doesn't have a model. I'm trying to find one that already has a model made, just because it's one less thing I gotta worry about. That doesn't. Typical. Oh, this is a wire wound one. This next one I'm gonna look up. Looks cool, but not really that useful. Oh, come on, give me something. Are none of these going to be capable? We probably don't need a wattage this high, honestly. That's probably what I'll have to do when I find out none of these have models made. Yep. All right. We're predicting 125 milliamps through each. So it's I squared R, right? V equals IR, it's I squared R, so current times voltage. So 3.4 times 0.125. It's 0.425. So a half watt will work. So let's try that actually. Okay, that gives a few more available. And they're a little cheaper, so here, let's try this one. Panasonic Electronic Components. We've been using a lot of their stuff lately. Yep, and it's got a model. Sweet. 1210. This is a big resistor. You can get an 0805 package for this sort of thing. Jeez. But I have a feeling this is going to require quite a lot of dissipation, so I'm just going to do this. R34, I'm going to take this out, and we're going to drop this in place. All right, I need to move all these changes to the board so that I can see how big this is going to be. So, whoops. Save everything. Let's validate. All right, update PCB document. Oh. What now? Unknown pin R34-2. Well, it seemed to handle that just fine. Anything didn't get moved? All right, we're looking good. Right, everything got moved around or something. All right, where's resistor 34? Here it is. Oh, that's not too bad. It is still sizable, but that'll be okay. can make that work. All right. So back to this. We need to add it to this sheet. Originally it was R3. We're not doing that anymore. This is a 27 ohm. New part number. Okay. So that's appropriate. And then we need to rename some things here too, which is fine. Okay. So I think this all works. I think this circuit looks good. We'll need to change this battery AV4 to be a different one for every single battery, but that's okay. All right. So let's add a new page. And we'll call this the chargers. And we're going to put 4 of these charging circuits on it, including this one we just made. Oh, didn't want that. There we go. Paste. Yeah, we're going to run out of room here, aren't we? 1. 2. 3. Oh, we're going to have to rename them all. And 4. There we go. All right, we got a lot to fix. That first one's good, except for... Let me update this. All right, so we've officially, I think at the end of this, used all of the teensy pins. Oh, we need 2 I/O for each charge status. I mean, do we though? Yeah, we probably do. Which means we're probably going to need a multiplexer or something. Ah, this is because I really do want to keep this extra I/O open just in case. This is going to get complicated. Oh, yeah, this is gonna get complicated. Although we just need to read the output, so we probably only need 1 output, and the rest can be inputs. And I think that works. Yeah, I do think that works actually. Charge status out. Goes to all the, okay, yeah. Yeah, okay, I think that we can still make this work. Absolutely. We're going to use up all our I/O though. Okay. We'll worry about that in a sec. For this, let's go ahead and rename these. Charge status in 1. Three and 4. I really wish we could, like, there was a way to do something where I could just go through and all these things that have the same names, just auto correct them to be not the same name, like use the next increment. I don't see that happening though. All right, I've already used up through Q19 on this board, so I got to do Q20, 21, and 22. Oh, man. All right. I guess we just work our way through every part. I'm trying to figure out a way to do this. Let's see, circuit maker. Rename duplicates or something like that. No, doesn't look as okay. Nothing useful. Yeah, I'll probably just have to go through and do this manually. Let's do it. Starting resistor 35, 36, and 37, I'm guessing. R35, R36, and R37. Okay, that works. Then Q, we said Q20. Q21. Q22. This is Q20 to 22 added on. Okay. This is U2. I've used up to U9, so this will be U10. U11. U12. All right, 10, 11, and 12 added on. Okay. Let's keep working our way through this resistor. I think we're up to, what are we on resistors? Like 37. So this is going to be R38. R39. R40. And this is going to be wild, putting this whole thing together. It's going to require so much effort. Which one was this one originally? R4. We say 38, 39, 40. Oh man, easy to lose focus here. All right, this 10K resistor. 6, we're at 40, so 41. R42. R43. R44. R45. R46. So 41 through 46. Okay. It's in C30, so what is the next set of resistors or capacitors? C30, so 31, 32, 33. All right, so C30 through 33, that is the 0.1 microfarad. Yep. What did you say 100 nanofarads? That's just 0.1 microfarad as well, right? Micro, nano. Yeah, it is. What's this one? Yeah, same thing. Okay. So C34, C35, C36. Man, a couple years ago, there was like a massive capacitor shortage. That would have been a nightmare to deal with right now. Because this stuff was just going out of stock and not going back in stock all the time. It was like the worst thing ever. Why is this one still throwing an error? R6. Where's there another R6? Oh, here. Oh, I misnamed this thing right here. There we go. 546. All right. Oh, wait. No, I don't want to do that one. R47. R48. R49. So 28. R47 through 49. Then we have 30. And then R50. R51. And R52. Okay. So 30. That was the 10K. So R50 to 52. Man, we were using a lot of 10K resistors. All right. I think this is all good. Now we just need to update V4 underscore 1. V4 underscore 2. And 4. Okay. And then we need to add the charge status in to the teensy. Let's do that next. So where is it currently? Here it is. With R31 as the resistor. Okay, I need to update it on the pinout here. So it's 1, 2, 3, 4. Okay. So this becomes in 1. All right, and the pin 34 is going to use one of them. All right, hold on. I might need to change where I put this divider at. I think I'm missing something. Pin 16 and 17. Oh no, those are, okay, those are the SD, and pin 34. Okay, yeah. So basically all these ones that are unused we're about to use. Cool. And this means we have officially run out of I/O. Kind of sad. All right, so pin 34 is going to be number 2. And then three and 4. All right, so pin 16 is 3. Pin 17 is 4. All right, a lot going on here. If I slide this out, well, that's kind of annoying, but I'll make it work. All right, so R31, and what are we on the resistors? Is it like 50 now? 52, so 53, 54, and 55. R53, R54, 55. And then a wire to connect everything up here. Okay. Then we need to add that here in our bomb. So R31. R31 is a 1K. 53, 54, and 55. All right, excellent. Oops. Thing. All right, that's good. Battery connectors are still there. They haven't gone anywhere. This charger thing up here. And this looks good too. All right, so next we need to do the battery connectors because I think that's where I'm going to put the balancing and everything. I think. Jeez. Upstairs neighbors are just stampeding around. All right. So let's see here. I guess we need to change these labels. _1, _2, _3, and _4. And then we need diodes that are gonna bring it all back to our input here. This battery AV4 needs to come out of one, like a set of diodes, and go right into that. So let's see here. I guess I need to figure out a good, like, a diode that can handle quite a lot of current, at least a couple amps. Lots of different types. I guess a 4-channel wouldn't be bad if you could do 2 amps of each. Oh yeah, this is going to be ridiculous, I'm sure. Alright, yeah, definitely a lot I'm not going to understand here. Alright, what does it take to get 2 amps out of something? A lot, apparently. Yeah, I just want something like this. These are expensive, though. Jeez. Maybe something like that. Drops 1.1 volts at 2 amps. That's okay, actually. That is actually perfectly okay. Let's inspect this. I like this one a lot already. Is there a graph of the drop? Let's drop. It said 1.1, right? Yeah, okay, yeah, that's right there. It's 2's right there. Most interested in 25C. Should be less than a volt of drop. I think this works. It all just comes down now to if a circuit maker already has the part. Probably not. This is kind of a specific thing. Nope. That's disappointing. I wonder if I can find a similar one. I want one that's not going to be insanely expensive. There's a lot of very similar parts going on here. But eventually I'm going to find one. Nope. Nope. Like I said, eventually I'll get there. Wow, some of these are insane. 800 volts, jeez. I'm thinking at this point, like, I'm having a hard enough time finding them that I might just have to create my own footprint. Here's a weird company. Nope. Alright, dang it. I'm gonna have to create my own. Alright. Just one more check just to make sure. Typical. Let's go look at the data sheet here. Make sure we can find a footprint. Yep. Alright, let's make a part. Actually, let's see if we can just find like a... I just want something basic, not a Zener. Oh, that works. All right, then we'll have to actually make a footprint. All right, let's drop this in. Designator 1, I guess. This is against both options. I'm going to do it in metric. Rectangular. Simple. Top layer. X and Y. 1.2 on the X. Y is 1.52. Uh, 3.12 plus 0.6, or half of that actually. Actually, no. Let's put this one at 0, 0. Uh, 3.72. And then as for the part, probably just need to draw a line real quick. Do 3D body and go from, oh wow, this is like way zoomed in. All right, so it should be 1.35 up. .625. It's too far. .35. Then we need to go over to 4.35. Oh, I did this wrong. Hold on. I think the way I did this actually made this kind of hard. All right, let's just go for a generic. That's fine. Up there. 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 And there. This is basically just me making it big enough. And how tall is this? 1 millimeter tall. Yep, that'll work. It's much smaller than that, but that'll be fine. Oh wait, I need to make sure that I got these designators right. 1, 1. This needs to be 2. Goes from 2 to 1. I need to put a marking or something, actually. I just realized that. Line. Hold on. Top overlay. Now let's do a line. All right. Diodes are directional, so it matters the orientation. So we need to do something to indicate that it goes this way. So this line being closer to the side will indicate that. All right. So save this, go here, edit this. This is pin 2. This should be designator 2. Okay, and this should be designator 1. Switch the directions. At least I think that's right. All right. Save this to the server. No issues, hopefully. All right. And now we can add this part. Here we go. Yeah. I'll have to do everything over. 1, 2, 3, 4. Okay. So D2, D3, D4, and D5, and these all need to get rotated. 180 degrees. Turn that off. 180 degrees. Oops. Okay. Let's see here. I need to move this over a little bit. A lot going on here. All right, and then this connects to everything. middle here. And this is the normal battery AV4. Okay. So that takes care of this. So now we've got everything in a... oh man, there's so much going on here. All right. So now we've got everything isolated in such a way that they all charge separately and feed into one line, but there shouldn't be any kind of leakage going back and forth. So now, what now? Okay, now we got to do the battery balancers for the 2 in series. This is tricky. We have to basically pull charge from one and put it in the other, in theory. So I was looking up some methods to do this, and one of the ones that I talked about last time that sounded kind of fun is the flying capacitor. And basically it's a capacitor that is switched from being over this battery to then being over this battery and back and forth, and whatever one has the higher charge will fill up the capacitor, and then it will place that charge on whatever one has the lower charge. Pretty straightforward in theory, but pretty complex design. Because we basically need some sort of timer circuit running, and then we need to clock it through a some sort of logic to give it a 50% duty cycle on each one. And I don't have any I/O running anymore. I don't have any more I/O on the Teensy. Man, though, if I did, that would make this a lot easier, wouldn't it? So yeah, we got to figure all that out. Through. Let's see what we can do here. I wonder if I could just use a 555 timer as some sort of like flip-flop thing. Trying to find a through-hole part or something. I mean, this is going to have a lot of switches, too, for each set of batteries. I might end up having to break these up into each of their own schematics, basically. Alright, let's save this for now and validate. I want to go ahead and move it to the PCB because it's going to get ridiculous. I'm sure it'll figure it out. All right. Unknown pin, failed to add. This is concerning. Oh, did it get everything? Okay. Oh, yay, more parts. Just so much going on. Oh, come on. Wow, there's so many components that we're going to have to fit onto this board. This is insane. How long have I been going for? I might actually take a break. Almost an hour and a half. I'm honestly really tired, and thinking through some of this is getting pretty complicated. I'm worried I'm going to start making mistakes. But at the same time, I do want to at least pick out a part for this next bit. We want the duty cycle on this to be like, or not the duty cycle, the frequency on this to be like super low. This is something that has to go pretty slow to work properly. I think the timer thing is good idea. Let me see here what this is actually quite a large data sheet for a simple device because these can get a little complicated. Trigger output, okay. Basically, they need this to be running all the time. Oh, that brings me to the other thing. I was going to add a switch to just cut off power completely to the main regulator, just to keep it from running itself dry in case like I added something like this. Supply voltage up to 18 volts. That's good. Output. Okay, so 15 milliamps. So kind of uses a lot of power. 15 milliamps, that could burn through quite a lot pretty quick. Although if we have all the batteries, we're going to have 100 milliamp hours. $800 divided by 15. So it would take this 586 hours. Or 3 weeks. 3.5 weeks to burn through it all. If it was the only thing on it. All right, so everything about this should be fine. Just assuming I can get it all wired up correctly. think I can. I want to see though. I probably need to make a new schematic sheet for this, but let me go ahead and see if I can drop the timer here. I want to see if it already has a symbol created. TLC 555 IP. TLC 555 IP. Nope, no package created. Dang it. I know it won't be hard to make one, but I really am getting tired of having to make all these parts. Let's see. Through-hole mounting type. Let's just see if we can find one. Wow, some of these get expensive. Jeez. I don't know how to say it. Maybe Hannah? Thank you for the follow. Oh yeah, that does have a part existing. Okay, we can place that. I think this will. I'm gonna go ahead and drop this in. It'll be fine. Okay, and then let me look at this and make sure there's no major issues with using this part. Same basic circuit inside. Raise a discharge, all that's the similar. Supply voltage up to 18 volts. And output current. I need supply current. Output current is up to 200 milliamps. That's not the supply current. I just want to know what the typical current is. Supply current. Under no load. Under 15 milliamps at the most. Okay. Typically around 10. Or depending on other situations. Okay. That's good. So that keeps it pretty low. So this will work. And it's not too expensive. It's only about 50 cents each. So excellent. So I have to put a large capacitor in between each of these batteries and then 2 switches for each one to move that capacitor back and forth between the batteries, and then a some sort of flip-flop or something to change this duty cycle to 50%. So let's see here. I'm guaranteed this is something that a lot of people have had to do in the past. So, yep, here we go. Here's a tutorial already on it. Threshold capacitor discharge. Okay, it may just be a pretty basic circuit to do it. Yeah, just a couple of resistors, a couple of capacitors, and it should work. There will be some more math involved though, with regards to like how long the capacitor needs to stay on each battery, because it needs time to fully charge, and then when you move it over, time to fully discharge, and that can vary depending on the voltage. So we need to decide a minimum threshold, like when they're close enough, probably within 50 millivolts or so. So 0.05 volts, that would be the ideal. Don't want it any bigger than that. All right. I am probably going to take a break here because I'm getting really tired and kind of lost in all this, and that'll give me something to do for next time, and that way I can think about it some more too. So thank you all for joining me tonight. I will be back on Thursday, and we'll figure the rest of this out, and then hopefully there's nothing else with the schematic we need to update. There could be though. And this part's looking awesome. All of these pieces. I don't know how we're going to fit this all inside the lightsaber handle yet. It's going to have to be a sizable handle, but we'll figure it out. All right. Well, see you later.